Hello everyone, today we will be performing linear variable differential transformer experiment. So the aim of this experiment is to understand the characteristics of linear variable differential transformer. This experiment contains three pieces of equipment. One is the oscilloscope, other is my LVDT training kit, and third is my LVDT assembly itself. So I'll turn on my equipment. So I've turned on my equipment. Now as you can see on this, the reading is at 6 centimeters on the positive side, and my oscilloscope is connected between my carrier and the ground. So the assembly of LVDT system is like this, as shown in this diagram. There is one primary coil and there are two secondary coils. This primary coil contains my carrier signal, and secondary coils don't have any signal, but due to the signal being an AC signal, the variation over time causes a change in flux in these two coils, which causes a EMF to be produced. Now there is a soft iron core in the middle which can be moved. This is my variable differential transformer part, and when I move this soft iron core, the amount of flux in both of these coils varies depending upon where my iron core is located, and due to that, different amount of flux is produced in the coils, which gives me a net voltage between the two of them. This net voltage is read by my trainer kit here. It is demodulated and read here, and when it is unmodulated, I can check it by switching this from here to here. As you can see, it is giving me an AC signal again, but this is my signal which is on the coils, on the secondary coils. Now I'll start taking the readings. I have to move this screw to move my soft iron core. As you can see, the reading here is changing simultaneously. I'll write a reading down at 5.5. At 5.5 positive displacement, my centimeters, my demodulated signal is at 176.8, and my unmodulated signal is given by VRMS 1.27 volts. Volts and millivolts. Now I'll again take a second reading at 5 centimeter. Again, you can see at 5 centimeters my demodulated signal is 165.8, and my modulated signal is at 1.22 volts. I'll take a third reading at 4.5 centimeters and 147.5, and I have 1.11. So I'll continue with these readings in the same manner, and when I graph these out, finally we get graphs like this. This is my graph for my modulated signal, and this is the graph for my demodulated signal. Modulated signal, since it is giving me the VRMS, it negates the effect of this, and I get a straight line going upwards while the other one comes downwards. The straight line nature of this experiment is the reason why this is known as a linear variable differential transformer. The linear part is for the straight line that we get. The variation of the movement of soft iron core is the relation between the movement of soft iron core with the voltage produced between the secondary coils, as you can see in this diagram also here. These are the secondary coils. The difference between the EMF between these secondary coils and the displacement of my soft iron core is linear, and that is why this experiment is known as the linear variable differential transfer. Thank you.